All right, let's talk about angles of rotation. This is going to take our understanding of the angles from the geometry level to kind of a new level for us. So we want to become familiar with the vocabulary that's associated with angles of rotation and how these angles of rotation then tie in with those trig functions that we reviewed in the last section. So we're going to get a little bit of vocab here, and then I've got a little bit of a demo that we can watch on some things. So that's a new thing for me to try on the video. We'll see how it works. So the standard position for an angle of rotation is with the vertex at the origin, and one ray or side of the angle is on the positive x-axis. Okay, so that's going to look in the picture over here. We've got one side is on the positive x-axis, and the other side can really be anywhere in there. I'll do it in a different color. So we might have the other side there, and so this angle is what we refer to as an angle of rotation in the standard position. Okay, it has two sides. The initial side is the one that is on the positive x-axis. That's the one I have in blue over there. Okay. And the other one, so let's label this. This is the initial side. And the other one is called the terminal side. That's the other side of the angle. Other side, or the other ray. This is our terminal side. All right, so this is an angle in its standard position. Let's see if I can demo this here. Here's just some random angle. It apparently, by measurement here, is 46.97 degrees. And we're going to put it in its standard position as it is. It just exists out there somewhere. But if we show a grid here, and we'll try to show some axes here as well. Let's see, that's probably under, I'm going to show all the hidden stuff that is along the way here. And so I need the vertex to be moved to the origin, and still at 46.97 degrees, and then I need the initial side to be moved onto the positive x-axis. So I'm going to move this point on that ray down onto here, and I think that's done with this command. And now here is what my 46.97 degree angle looks like when it is in its standard position. It is congruent to where the angle was before, but this is going to enable us to do some other things with it and refer to it as an angle of rotation. So an angle of rotation is the angle formed by the terminal side rotating from the initial position. So our vision of this is that we've got both rays laying along the positive x-axis. Let me see if I can demonstrate that in my document over here. I think I've got something else stashed over here that's going to allow me to do that. Let me try to move this around a little bit. So, I'm going to get over here where we can see this, and see if I can move that point around here. Okay, so I have my terminal side and initial side on there, and then the idea is that I begin to move that terminal side away from that, and you can see it rotating and pivoting at the origin where the vertex is, and this is what I refer to, why I can refer to it as an angle of rotation. It's formed by that rotation. Now, we get a positive angle of rotation when that rotation is counterclockwise. So if I look at this and I consider this angle, I'm going to just draw myself another picture in here with an initial side and a terminal side on it. And if I rotate it this direction counterclockwise, then that is a positive angle of rotation. Okay? We get a negative angle of rotation when that rotation is clockwise. So on this, if I view this as starting and moving in the counterclockwise direction, I get a positive angle. But if I viewed it as moving that thing around this direction, then I could also view it as being a negative angle. Okay, so the direction that I'm spinning makes a difference of whether I'm calling it positive or negative. We need to understand that, which direction is which. Okay. So a coterminal angle or coterminal angles are one or more angles of rotation whose terminal sides coincide. Okay, that means they have the same terminal side. Okay, so my demonstration of that, this is my big show-off one right here. Okay. I've got a particular terminal side in here. Okay, I guess I didn't have that drawn in there. So, okay. That didn't start that where I thought it would. Let me erase some traces here. This was supposed to start down here, and that was supposed to start in there. Okay. And I'm going to put a separate ray in here. Thought it was. So let me stick that out here, and this will be just some other side that's here. And now, okay, as this moves around, if I try to, I'm going to try to stop it in the place here. That's almost where this other side was. But what it's keeping track of here, you can see in the way that this angle is marked, how many times it has spun around. So it started over here, and there was a point when we traced along here, and it came around and maybe stopped at this point right here. It had done one full rotation, and that would be in the positive direction. That would be 360 degrees. And then it went around again another 360 degrees. Okay, so that's 720 degrees. We are used to hearing about angles that are bigger than 360, not when we're talking about triangles. Certainly in triangles, we're stuck to 180 degrees, but we know what it means when somebody says they did a 360, or we're watching the X Games and somebody did a 900 something. Okay, those are references to multiple angles, or an angle of rotation where there's been multiple rotations. Now, there are several different places, like right here, and right here, and right here again, where the terminal side hit the terminal side of the angle that I had marked. All of those angles are considered coterminal. Okay, they have the same terminal side. Their terminal sides coincide with each other. And that's what we mean by coterminal angles. And then a reference angle. I'm not sure I have this necessarily in there yet. Nope, I didn't draw any angles in there yet, and I got other stuff going on here. So let me go back to this, and we'll talk about what a reference angle is. So a reference angle is the acute, there's a word from geometry that you should remember, between 0 and 90 degrees. It's the acute angle formed by the terminal side. We say a lot about the terminal side. Once that initial side's there, nothing's really going on with it. So the acute angle formed by the terminal side and the x-axis. Notice in this case, we didn't say the positive x-axis, we said the x-axis. Okay? So when we are talking about that angle, if I go up to my picture that I had here before, my reference angle for this picture would be the angle formed, the acute angle that is formed by the terminal side and the x-axis, and so that is this angle over here. It will always be positive when I refer to it, okay? And we can see that it has something to do with our angle of rotation here. In particular, it is the supplement of the angle of rotation that we had marked here with this green terminal side, okay? Sometimes it will be exactly what the angle of rotation was. It just kind of depends on where that terminal side is in relation to the positive, or in relation to the x-axis. So let's try some sample problems here. Find the values. Because we are putting this on an xy axis, it now ties together and gives some algebraic meaning to the geometry that we're doing. So find the values of the trigonometric functions for the angle of rotation whose terminal side passes through the point 2, -3. So here is the point 2, -3. We have a terminal side that is passing through there. We know that our initial side is right here. This is our reference angle. Down here, a positive angle that I could find with my knowledge of trigonometry, but that's not in particular what it's asking me to find. Okay? I can, in this process, make myself a little right triangle here. And I can label the sides that I have so far. I know that this is 2 on that, and this red side that I have here, I'm going to label that as a -3. And I can find this blue distance right here with the Pythagorean theorem. So I can do 2 squared plus -3 squared equals, we'll call it x for now, x squared. And so that's 4 plus 9 is x squared, and x is going to be the square root of 13. The angle, the reference angle here that I'm talking about, this is my angle of rotation is theta. And so from that triangle, I know that sine of the angle, which is the opposite over hypotenuse. The opposite side is -3. The hypotenuse is the square root of 13. So this is -3 over the square root of 13. Okay. My cosine is adjacent over hypotenuse. The adjacent side is that 2. The hypotenuse is the square root of 13. So the cosine is 2 over the square root of 13. And my tangent is the opposite over the adjacent. That's going to be the -3 over the 2. Okay? And so I can come up with the values of the trig functions for that angle based on the fact that it is in standard position and I found a point that its terminal side passes through. Okay? I could do any one of my inverse trig functions on here to figure out what this angle is. but we're going to talk more about that in a later lesson. All right, example 2, find two angles, one positive and one negative, that are coterminal with 147 degrees. Okay. Well, if I try to look at something that was 147 degrees, I'm going to approximate that in here on the picture. So I've got my initial side, my terminal side. I know this is 90, this would be 90 plus another 57 degrees is maybe off in this direction somewhere. I'll say that's my angle of rotation of positive 147 degrees. So if I want something that is coterminal with that, well, I could decide to come back the negative direction and give a negative angle that way. And what I can see from the picture is that based on that, the two of these things are going to add up to 360 degrees. So it's like 360 degrees minus the 147, but actually what I need is probably the other direction from that, 147 degrees minus 360. So if I do the 147 minus 360, I get negative 213 degrees. So negative 213 degrees is exactly the same thing as positive 147 degrees, because 213 and 147 will add up to 360. So there's the negative one. If I want a positive one, well, I could just take one more lap around before I get there. And one full lap around is 360 degrees, so I could do 147 degrees plus 360 degrees. Okay. 147 plus 360 is 507 degrees. Okay. So there is my positive angle and a negative one that are coterminal with 147 degrees. I have an infinite number of choices. I could keep subtracting 360 from this. If I took another 360 off of there, I'd have negative 573 degrees. That is also coterminal. I could add another 360 onto this. That'd be 867 degrees. That is coterminal with 147 degrees. Okay. All right, and the final example, what is the reference angle for an angle of rotation with a measure of negative 897 degrees? Okay. If I try to figure out roughly where that thing is and see if we can come up with an approach here. So negative 897 degrees, if I go once around here, there's negative 360. If I keep going in that direction, another 360 would take me to negative 720. Okay, well, how much do I have left from that point? Looks like about 177 left from that point. So if I continue another negative 177 degrees, I know if I made it all the way to that line, that would be negative 180 degrees. So this red part is negative 177 degrees. And my terminal side then must be over here. And the gap that's in there that's formed by the terminal side and the x-axis is this little angle in here, which appears to be 3 degrees. So what is the reference angle for the angle of rotation with negative 897 degrees? The answer is 3 degrees. It's a acute angle. It's got to be positive. And that's going to have a lot to do with some of the trig values that are in there. It lets us really focus on the things that are just between 0 and 180 if we know how to find those reference angles. So other ways that we could approach that, certainly we could take the negative 897 and start unwinding it by adding 360 degrees at a time. So negative 897, negative 897 plus 360 gives me negative 537. Okay, still more than one full rotation, so I'll add another 360 onto that, and that's where I get the positive 177, and I should have a pretty good idea, or sorry, negative 177, pretty good idea where negative 177 degrees falls, because that's in the first rotation. It's just that red part on the diagram there. All right, that is the bulk of the information on angles of rotation. Hopefully the extra demonstrations helped with the understanding there.